Alrighty. So with that, I wanted to introduce Wayne from Infinera, who's going to talk to us about SDN in the transport network.
And where are the buttons? Sorry.
You can hold that.
I can hold that. Okay. I can hold this. Sorry. All right. Thank you very much. I'm Wayne Walford from Infinera. I'm going to talk about SDN and particularly bring it into the transport network. Can you hear me in the back? Okay. I'll turn it up a bit. All right. So SDN, why is the industry interested in SDN, right? Well, as you guys, and you guys I think are all probably very familiar with SDN being in the data centers primarily, right? You know, in the data centers, you've taken and virtualized computers, computing power, data storage, and then started to do that with networking, right? So that allowed you to bring IP routers, Ethernet switches into the business applications, orchestration of those resources to be closer aligned with your business, giving you, basically virtualizing those resources, making them programmable, getting a global view, right? So you can be optimal, and getting application driven, right? So basically getting application control over the infrastructure, the data net infrastructure in the data centers. Now we're looking to extend that paradigm, those learnings, those technologies into the transport network. Now, there's some interesting differences between the packet world, which is where most of SDN has done so far, and the transport world. First of all, there's a technology difference that I think most people understand. Packet's connectionless, right? It's dynamic flows, right? Transport is connection-oriented, static pipes traditionally, right? But the other interesting aspects is, what you've seen in the packet world is a lot of control planes, vendor-specific control planes, really automating a lot of features. Whereas in the transport world, you really haven't seen that so much until just recently, right? You've seen more of a paradigm of individual cross-connects being made primarily by a management system, right? A management system would create the path, would have an end-to-end view, and then each individual element would be told what to do. On the other hand, if we look at the packet world, these systems have had a lot of automation, but they've typically been very closed. That is, there has been very little programmability from the outside. Where in the transport system, again, we haven't seen so much of the control plane paradigm, but we definitely have seen open and programmable interfaces, primarily because it's coming from a telco background, and they had big OSSs that they wanted to use across their infrastructure. So if you look at the motivations for extending SDN to the transport world, first of all, you see today's SDN is primarily around the data center and around the IP network in the data center, right? And then tying, basically allowing applications to see that network, control that network, and virtualize that network. So now, to extend it to the transport domain is to bring that transport OTN, which is layer 1 switching, DWDM, which gives you huge scale on fiber, into that network as well. In addition, typically, right, at the transport layer, you start to see the multi-domain problem. Most networks that have multiple domains are tied together at the transport network. So when you talk about going to transport domain, SDN, bringing SDN into transport, you also think of not only multi-vendor, multi-layer, but you think about multi-domain. And if we can bring SDN into the transport layer, right, you'll get, we'll be able to do multi-layer optimization, IP, transport layer, and multi-domain optimization, right? And then allow the applications, right, to really drive the usage of those resources. Again, not only multi-layer, but also multi-domain. So the central sort of aspect to the bringing transport SDN into the transport is basically a transport SDN controller, right? This provides you the orchestration, it provides you the virtualization of the transport resources, provides a network, an abstraction of that network to the business applications, so that they can basically orchestrate and use the resources. One of the keys here, we believe, is though is that transport networks have gotten much more intelligent in recent years, bringing in more capabilities, bringing in more than just DWDM, which means you're trying to manage waves, but bringing in switching technology, bringing in packet functionality, right? So that you can now access, instead of looking at a transport network as waves, you can look at that as a pool of bandwidth that can be used. Bringing in intelligent control planes allows you to have better control over that, right? So we believe it's important that we actually virtualize that transport network to the SDN controller as well, right? So that makes the programming, the creation of the transport controller much easier, right? So you can then try to get to that multi-domain management that we were talking about earlier, right? So we're looking to get their multi-layer, multi-vendor, multi-domain integration and abstraction to the business applications, so you can get much more flexible and rapid bandwidth usage, right? Much more global optimization of the resources, right? And much more speed of the new services or the bandwidth, or how you want to use that bandwidth, or how that business applications want to use that bandwidth. So I talked about a transport SDN controller. I wanted to give some concepts of what the scope of that can look like. And the Open Networking Foundation has done some use cases there that we're going to present. Right, so the first one is a pure enterprise network application, right? So where the SDN controller is in the enterprise, the IP network is in the enterprise, the DWDM, the transport network, is in the enterprise. In this case, the SDN controller base is able to orchestrate all those resources on its own. Second case is where a network provides the transport layer. So the enterprise is providing the IP network. There's an enterprise SDN controller. The transport network is provided by a network provider. They have basically a network provider controller that's then put an abstracting view of that network to the enterprise. So for example, a virtual private network, right? Maybe you present just part of the network of the overall transport network, the part that that enterprise has control over and can use. And then the enterprise controller there is then orchestrating the IP network and basically that virtual network. And the third case is where both the transport and the packet network is being provided by a service provider, right? And the service provider there would also be providing the optimization between the packet layer and the transport layer, right? And then they're presenting a higher level abstraction to the enterprise and the SDN controller in the enterprise, right, of the packet network optimized for the transport network as well. So those basically gives you a scope of how the transport SDN can fit into the different business scenarios. Sort of key aspect to transport, bringing SDN into the transport network beyond the controller itself, is an open transport switch, basically a lightweight virtual switch abstraction of the switch that we call the open transport switch, right? That basically abstracts the network element, simplifies it, and presents as a more generic abstracted view to the SDN controller. Covering resource, topology discovery, the connectivity, monitoring of services that are created, and provisioning through OpenFlow. Right. With the SDN model, there also is a couple ways you can control that. Right. One is what we call the explicit model. This is a very traditional sort of telco, I'll call it a telco model, where the SDN controller goes to each individual node and makes each individual cross-connect, right, hop by hop provisioning, right? And a lot of the enterprise SDN is doing that same model. Second model is what we call implicit model, where in a domain, you basically get the whole domain abstracted up to the controller. So the controller doesn't have to do node by node, it only needs to do domain by domain. Each domain there is presented as a black box to the SDN controller. This really facilitates, makes it much easier to have a multi-domain orchestration, right? Much easier to create an SDN controller that can control multiple vendors' equipment and then orchestrate across multiple domains. We're leveraging the control planes that are emerging in transport networks. So you have these two models. One, basically hop by hop. Second one, where you're using the intelligence of, in this case, the transport network to make it simpler for the SDN controller, but I think allows you overall to get a more complex orchestration over multiple vendors, multiple domains, multiple technologies. So now I'm going to talk about a couple of data center related applications. First, I'm going to talk about with a network service provider providing on the network. Secondly, where the enterprise controls the network itself. And in the second case, we actually have a demo that we did with ESNet, so I'm going to talk about that demo in particular. So here we have a model where the network service provider provides the network. A subset of that network is abstracted, right? A virtual private network is being managed by the client controller, right? You can basically do bandwidth on demand with that model, right? You can see you have a subset of the network. You have bandwidth that you have the rights to configure. You can use the SDN controller to configure that. Right? That same model can be used for other services, right? For network as a service, where the whole network is being outsourced to the cloud, right? Ability to increase bandwidth for packet VPNs, and reconfiguring the network in case of application router failure, for example, right? You can have a router fails, you might have a backup router or an in-for-one router backup, and if a router fails, I just basically reconfigure the transport network. All the flows that were, all the circuits that were going to the router that fails, now can just go to, the router that I have as my backup. And it can be pretty much, from an IP layer, right, it can be basically transparent. Right? You don't have any change of the topology in that case. Right? You can also do, basically, as I mentioned, bandwidth on demand, you can do time of day. You might want to change how much bandwidth goes to different data centers. As you with virtualized data centers today, right, use different resources in different data centers based on time, cost of day, time of day, the cost, right? You can use, you can modify the transport network to facilitate that, getting more bandwidth at different parts of the network, different data centers at different time of the day. So now I'm going to talk about the demo with ESNet. So ESNet has a very large network in the U.S., connecting a large number of research, government and commercial research labs, a lot of data, 10 petabytes of data a month, and that network is growing 10 times every 4 years. One of the issues they have is they have a lot of typical business applications, short bursty applications, but they also have a lot of really big data flows that related to the scientific nature of high energy physics. And those flows in a normal IP network will basically just crush all those small bursty applications. So their solution for that was to have an SDN controller that allowed them to do bandwidth on demand. So when you have the big flows, right, you can make a reservation between the two endpoints. Actually, we go to the next slide here. Right. So this is the GUI for their SDN controller. So here you can basically have your originator and destination. You can reserve a certain amount of bandwidth. You can set a quality service around latency, right? And you can have a time that you want to have this circuit for. So using the SDN controller, they can basically create these bandwidth on demand flows to keep the big data off their IP network. So they do directly put that data onto the transport network. All right. So in this demo, ESNet has an SDN controller called Oscars. Secure. I forgot for the acronym at the moment. Sorry, but that has a bandwidth on demand application. Using OpenFlow, it's connecting to a network of 4 DTN nodes, 2 of them which are in their Brookhaven lab, 2 of them which are actually in their production network. And they use that, and each of those DTN networks from Infinera have the OTS model implemented, right? And it can be controlled with OpenFlow for provisioning, right? And we set up here 3 different paths, right? One through their production network, one through gray optics back to back between the 2 nodes in the lab, one using DWDM connecting the nodes in the lab, right? Each of those have a different data, a data path available, a data amount available. Bandwidth, this is 20 gigs, 40 gigs, 100 gig. Each of them have a different latency. Each of them have a different hop counts, right? And then the SDN controller then can select a path based on, right, so as I mentioned, when a customer of Oscars wants to make a circuit reservation, they reserve bandwidth and a delay and a time of day, right, and a destination. So using that, the SDN controller can then set up or provision a network, and it can choose 3 different paths there based on the quality of service metrics, right? And in this demo, we did actually both implicit and explicit routing provisioning, right? So explicit meaning the controller had to know the whole topology of the network, had to know, basically figure out what were the service metrics that can be obtained on each path. And also we did implicit, which basically allowed the network itself, using its control plane, to determine what were the quality of service metrics. Based on the quality of service metrics of the request, what was the best path to choose. All right, and then, so when the circuit's active, you can see you can also get on the Oscar system confirmation of that. So just in summary here, I think the key things is that extending SDN to the transport layer gives you opportunity to really get multi-layer, multi-vendor, and multi-domain orchestration for optimizing the network across all those different domains, right? Ability to speed up the delivery of services. If like I said, the transport network has always been programmable. What it hasn't been is really been tied to the applications, right? Extending SDN to the transport layer will allow basically applications to get the access to that real-time bandwidth as it needs it, can orchestrate it, can change the network as it needs to be the most optimized. Right? And it makes it much easier, like, as I was just mentioning, to see the network and modify it. Any questions?
Don't be shy, folks. There you go.
Hi, I've got a question.
Sure, thank you.
So coming from the IP world, I'm pretty naive about the transport layer. When I think of an IP topology, I think of various links and nodes where each link has, say, metrics and capacities associated with them. What type of topology information would be available in a transport network?
Okay, good question. So, depending on basically, so transport layers, there's actually in the transport network, there's actually a fair number of different vendors have, I guess, how much intelligence is in that node, right? So some of the transport nodes are just basically point to point. Some of them bring in more intelligence. For example, in this case, with an Infinera network, you also have a switching element in addition to the DWDM element, right? And you have a GMPLS control plane. So actually, you would get from the transport network there a connectivity map very similar to what you would see in IP, and you also get actually quality of service metrics mainly around bandwidth and latency. Those are typically the two. So available bandwidth, right, and latency are typically the metrics that people want, although sometimes a distance is an important metric, right, and hop count for a connection is another important metric.
Perfect, thank you.
Welcome.
Just one quick reminder, when you come up to the mic, please state your name and your company affiliation. Thank you.
Okay.
Yes.
Victor Liu, Huawei Technologies.
Okay.
One question regarding to this real-time bandwidth on demand.
Sure.
What's your targeted like time to provision this 100G? What kind of distance you're looking at?
So, I mean, the network itself is established, right? So within, right, and we were using integrated switching, OTN switching into nodes. So actually it was basically it's seconds, right, to provision that.
How about the distance you're looking at?
So, I mean, this was in a lab. You know, the distance doesn't really matter in this particular network. This was a couple hundred kilometers. But we actually do the whole thing on a nationwide network, right? Because you have the integrated switching and the GM+ control plane, you're able to basically abstract, abstract that to just a pool of bandwidth that you can control very quickly. Right? The OTN switching allows you to basically make those connections immediately. The control plane allows you to do, connection by connection.
Thank you.
You're welcome. All right, thank you.